Hello and welcome to another training stream brought to you by Epic Games. I'm Zak Parrish, and today we're going to be building a prototype of a 3D puzzle game that I put together. Now, typically my live streams that I run tend to run over a little bit. I'm going to try to keep this one shorter than usual, but we'll see how that goes. I am under a little bit of a time constraint today. So I've got some notes that should keep me from at least from building the wrong game. That's something. But let's take a quick look at what we're going to be building today. So over here in Unreal, I have the game actually running. This is kind of a rough prototype of the prototype, if you will. So you see you've got this 3D sphere, and it's covered with these buttons, some of which are lit up, some of which are not. Now when you click on a button, like so, it toggles the state of that button. So it goes from being lit to dark or vice versa, and it also toggles the state of the 5 buttons surrounding it. What I want to do today is actually get the puzzle built, get the motion in place, get it so that the buttons are behaving as they should. Hopefully also go ahead and get the UI built for it, which at that point means the game is pretty much done. The only thing we won't be doing is we won't be adding a set win condition or lose condition. I will leave that up to you if you make it this far with a similar game on your own. But at that point it's pretty easy. You just have to detect when all the buttons are on and then play a tune or something. Now, to get things kicked off, let's take a look at some of the important classes that we will need in order to build this. So for starters, we have the obvious one, which is the actual game itself. Our game is going to be a pawn. So I have a pawn here called Ball Puzzle Pawn. I'm just going to open it really quick in the blueprint editor, which I will bring over to the screen that at least you guys can see. And you can see there's actually a lot of stuff going on here. Now this is a commented version of the graph, and of course we won't be doing all of these comments, but obviously there's quite a few things going on. We're going to build this up layer by layer, hopefully in a way that makes it pretty easy to see not only what we're doing, but why we're doing it and why we made some of the decisions that we did. Now some of the other classes that are going to be really important to us include a special class just for the button. Now this is going to be a parent class. We're going to make a lot of children classes from this. So you're going to learn about parent blueprint classes and child actor components, which are going to be used all over our puzzle. We also have to use a special player controller. Honestly, for the most part, really the only thing we care about in here is this one little checkbox for turning on the mouse cursor. Now, if we take a look at some of the other classes, we've got a game mode and a game state. Honestly, for a game as simple as we're building today, we really don't have to have a game state. I'm setting one up in such a way that the mentality that I'm using is that the game mode is kind of like the rules for our game. It's like the rule book that you refer to make sure the game is being played correctly. But actions that are performed on the game and like what the game is up to at any given moment, those are going to be passed down to the game state. But that's more of a philosophical thing. If you wanted to handle it a little differently on a version of this of your own, you could totally do that. Now, a couple of other really quick things before we jump in and start building. There are some things that are done for us so that we're not building the entire thing completely from scratch. For example, the puzzle ball itself, here's the static mesh for it. We can kind of zoom around it. You can see it's just a ball with 12 holes in it. If you are like, hey, how did you build that? Real quick, I did it in Maya. You can grab the soccer ball primitive, make extrusions of all of the pentagonal faces, and then smooth the whole thing, and you're done. Likewise, we have 12 different buttons. Each one of these buttons is based on where those pentagon faces were on the soccer ball. This just helped me from having to figure out mathematically where each button should be placed on the surface of a sphere, because that sounds like really painful math that I don't want to do on a random Tuesday. Now, on top of that, I've gone ahead and built the materials for us. These are super simple materials. As you can see here, it's just some Fresnel coloring with a puzzle color that if you really wanted to, you could change. And then for the buttons, we have the ability to change the button color if you really want, though we probably won't mess with that too much. The important thing is that we have a glow amount and a control over how much Fresnel exponent we're using. And that is being governed by a single parameter called state, and here's how it works. If I take state and set it to 1, the button just turns to a nice soft glow. If I set state to 0, it goes back to being kind of dull, but it's still got the kind of Fresnel on the outside. Now the reason I use Fresnel is that these materials are currently unlit, so this means that we can build our game without having to worry about lighting, And when we're done, it should deploy very smoothly to a mobile device. Okay, so with all that out of the way, let's minimize this, and let's go to our starter project. Now, the startup project is pretty much the same thing, but none of the blueprints are here. So we still have our materials, we still have our meshes. There are a couple of textures here that I'll be using for the UI, but we'll get to that when we get to it. So for starters, let's begin by building up our levels. Let's go to File, go to New Level, something that is empty with nothing in it, and immediately save this. I'm so horrible about this usually, so be better than I am and remember to save your levels. We'll call this the ball puzzle level. Awesome. Now that got stored probably at the root of the content folder. I don't really care where it ended up. Actually, it looks like it ended up in the maps folder, which is super nice and convenient. So with that done, let's go ahead and start building up some of these blueprints that we were talking about. The first one we're going to create is our pawn, and to do this, we're going to build a new folder, and it's going to hold all of our blueprints. Awesome. Now, inside here, blueprint class, make sure you select pawn. You could theoretically choose something like actor and then change the parent class later. I have seen that cause some wonkiness though. So choose pawn. And we will call this the ball puzzle pawn. All right, now let's jump inside this so we can go ahead and start setting it up. The good news is the setup of this class is actually pretty easy, at least at first. In fact, I'm going to try to make it so that everything we do is going to be easy, but it's just like a lot of little easy things that stack up and make something that is, I guess, more intricate than the sum of its parts, or some phrase that sounds really cool and mysterious like that. So here in my meshes folder, here's the puzzle ball body. I'm just going to drag this over into the components list, and so it automatically pops up as a component, which is awesome. Next, let's go ahead and add a camera, but typically whenever I'm putting a camera in a pawn, I will tend to put a spring arm on it first. This may or may not be the best practice ever. It just keeps things straight in my head in case I just want to have some sort of intermediate object, like a helper, in between my camera and whatever it's attached to. So I do this mostly out of habit. I think of it like a selfie stick. It makes me happy. So now let's add a camera to stick on the end of our selfie stick. We'll go ahead and parent it to the spring arm, like so. Now, here's the thing. The default field of view of the camera, which is like 90 degrees, makes the ball, well, it adds a lot of depth to the ball, which is great, but if we can remove some of that depth, it becomes easier for the player to be able to see more of the buttons at once. So what we're going to do is take the field of view of this camera and pull it down to 10, and then we need to slide the camera back by some amount to figure out where it should be placed. Unfortunately, right now, in the Blueprint preview window, we don't get a preview of what our camera looks like, which is okay, not the end of the world. We can just grab the pawn, drag it anywhere into the view, and then we get our little picture-in-picture window down here. So now all I have to do is slide the camera back until this guy fits in our view. I'm going to give it a little bit of buffer room around the outsides of the screen, mostly so that later on I have some room to fit a UI in, though if you wanted to keep it up close and then scoot it back later, of course that kind of thing is going to be really easy. Okay, so we have camera, we have the selfie stick, everything is looking good so far. Let me compile and save. Let me refer to my notes, make sure that I'm, again, still building the right game, because heaven knows I could end up building a completely different game if I'm not super careful. All right, so once we've got that, we need to set up our player controller. So let's right-click. We're going to make a new blueprint class, this time based off of player controller. This one's going to be really simple. We'll call it ball puzzle PC or player controller, whatever you want to call it, as long as you can identify it later. We're going to open it up, and really the only thing we care about is this show mouse cursor checkbox. Make sure that you have this active. And we'll go ahead and compile and save. Now, there are a few things we're going to do to cheat just a little bit. So let's go under Edit, and actually we're going to be cheating a lot throughout this game. There's no such thing as cheating in game development, I guess, as long as all the ideas are yours. Let's open up Project Settings, and let's go under Inputs. Now, we want to make sure that Use Mouse for Touch is checked. If you're building this project on your own, depending on whether or not you chose this to be a mobile game versus a desktop or console game, this may or may not be checked, so make sure that it is on because we're going to be leveraging that ability. Now also, the next time we hit play on this game, so when I built this, I did use the mobile version of the game when I was setting up the project, and that means that the touch interface is going to be visible, so I'm just going to clear that out. I don't even want there to be a touch interface. That's the two little circular sticks that appear on the bottom of the screen. So we'll go ahead and turn those off. Now earlier I said this was cheating. The reason this is actually cheating is that we're going to be using the mouse input for touch, so we're going to build the game up like a touch game, as if we were building it from mobile. It's going to work just fine on PC because we're telling the game to use the mouse in the absence of a touch device. But the benefit here is that when we're done with the game, we don't have to do anything else that is special. We can just deploy it right to a mobile device and it'll just work. On top of that, because we're using unlit materials, we're not bothering with lighting, the game actually becomes quite simple, and it should run on a wider selection of mobile devices. I'm not going to say many or most or whatever, anything that could get me yelled at later. So next, we need to set up our game mode. Why? We've got a pawn, we've got a puzzle, we got our player controller, but we don't have anything that is instructing our game that we need to use these two elements. So that's where the game mode comes in. So let's right click, let's make yet another blueprint class. And this will be based on a game mode. We will call it Ball Puzzle GM for game mode. We'll open this up. And again, this is really mostly about changing up some settings. So over here on the right-hand side, we have a default pawn class. We're going to set that to our ball puzzle pawn. We have a player controller class, which we should make sure we set to our ball puzzle player controller. Compile and save. We will definitely be making a few more changes in here as we move forward. For now, let's go ahead and close out anything that we're not actually working on at the moment. Let's hit Control S so that we won't lose any of our work. And a couple more things. First, I'm going to remove this version of the puzzle from the screen, at least for the time being. Let's go under our project settings one more time. We'll go under maps and modes, and we're going to turn on, actually let's make sure that the ball puzzle level that we just set up, which by the way, I can't spell level, so if you notice that and you're snickering, that's cool. We'll make sure that we set up the editor startup map and the game default map to be that map. And then we will also set the default game mode to be our current game mode. This just means we won't have to deal with that later, which will be super nice. Now if I hit play, we immediately jump in, we see our ball, so we're actually looking through our pawn, just like we thought we were, and we still see the mouse cursor even though the game is playing, which is great. We're going to need that as we move forward. So let's go ahead and stop here. I think we are pretty much all set to go to start setting up the motion of the ball. So the way we're going to set this up is that now that we've got our pawn, now that we've got our game mode, which is telling us to use our pawn and also use our new player controller, so we have mouse control, we're going to start layering systems on top of one another. And one of the most important systems is going to be the motion of the puzzle. We want to be able to drag around with our finger or with a mouse button and cause the puzzle to rotate around in an interesting way. Now, I'm going to break away and do story time real quick. The game that you're watching me build today is actually the first game I ever tried to build in Unreal Engine 4, ever. So a long time ago in a galaxy far, far away, I started working with Epic Games for the first time. Unreal Engine 4 is one of those things that nobody had ever heard of yet, and I had to learn it. And so I took on this task of building this little puzzle ball and having to use it to figure out Blueprint. A week to a week and a half later, I was only about halfway done with the puzzle. It didn't work very well, and I had no idea what was going on. So when I got pinged for this live stream last week, I was like, you know what? I remember that game. Let's go try it again. So I tackled it again 3 years later. I had the whole puzzle done in a couple of hours to tell you kind of how, not just the way your skills will grow if you keep using the tool, but really how the tool has grown. Because a lot of the things that I'm using today to make this puzzle didn't exist a long time ago. So that's exciting in its own way. So jumping back in, over here inside of our pawn, we want to be able to drag the mouse and cause the ball to rotate around. This is problematic if you overthink the problem of 3D rotations, because it's really easy to think that what you want, here actually let me hit play so you can kind of take a look at the game. It's easy to think that what you want is to click on a spot of the ball and drag, and then that spot of the ball just follows under your mouth, under your mouse. Kind of like Google Earth does when you zoom way out and you kind of rotate the planet around. You can do that, but that's a lot of rotation math to do that. I have a much simpler setup that's very, very easy to do, and that's how we're actually going to build this up ourselves. So let's begin. Actually, let's stop playing. Here inside the pawn class, we're going to start off with a touch node. So touch, it's just whether or not you've touched the screen, yes or no. It's always a good idea the first time you get this set up, depending on how you've built your project. I like to test this as soon as I get it up and going. So I would compile and save and then jump into the level and hit play. And make sure that when you click, it says hello. That just makes sure that you set up your, use the mouse button as your touch input properly, because if you didn't, then that can be a problem. So now, from the touch node, we need to figure out where on the screen they click. To kind of give you a high-level overview of what we're going to do, we're going to record the moment you click the mouse. We'll get that coordinate for where you clicked on the screen. And then as you drag the mouse, we're going to figure out how far you drag. What is the length of that line that you just created by dragging the mouse? Based on the length of that line, we're going to rotate the ball faster in the direction that you dragged. Now, if you didn't drag, if you just click the button and then let up really quick without moving the mouse, we're going to register that as a click, and then we'll manipulate the puzzle. We'll actually turn the lights on and off. So to get started, we need to figure out how far the mouse was just dragged. To do that, first off, we need to record the location of the mouse when you clicked. So we'll begin by getting the controller that is controlling this pawn. So that's just the get controller node. Next, I'm going to cast that to a player controller, to a specific player controller, to our ball puzzle player controller. Now, you can totally do this, right? As soon as it's pressed, you can cast to this guy. That works just fine. I don't want to have to actually test whether or not it's true. I'm sure it's going to be true. I can't think of any reason why it would never be true. So I'm going to convert this to a pure cast. You can just right-click and choose that, and now we don't need an execution wire. When this succeeds, we just roll out from there. Now from here, we're going to say get mouse position. And this tells us where on the screen we clicked, excuse me, in X and Y, and it does this in pixel values. So if you're on like a 1200 by 1200 screen, you click right in the middle, it should be 600 by 600, for example. We're going to take this and store it inside a vector. So let's make a vector out of it. And we're going to keep it simple. We'll just plug X into X and Y into Y for the time being. We'll leave Z or Z at 0. And now once we have that, we want to store this. So I'm just going to right click on my return value, promote this to a variable, and we'll call this click. Actually, let's call it mouse position. I don't really care what we call it, but I think it should be descriptive. So mouse position. Cool, I can spell that one. That's awesome. So I'll pull this up here and we'll connect this over like so. So the moment the mouse button goes down, we are recording where the mouse location was, which is awesome. Next, we need to figure out how far the mouse has moved after the mouse button went down. We're going to test for that as soon as the mouse button comes up. You'll see why shortly. If it's a little confusing right now, hold off, take notes, and then when you get back to it, you'll be like, oh, I see what he's doing. So let's branch, or if you still don't, ask a question later, and we'll get you sorted one way or another. So we have a branch. Again, this is just an if statement, if you don't already know that. So now we're going to take this vector that we made. Actually, you know what? Let's do some comments here to help people out. Gets mouse location on click, then stores. Also, for now, I don't want to deal with begin, play, overlap, or tick. We'll use some of those later, but I'm just going to delete them to clean things up. Okay, so now we have that vector. Let's take it and we will subtract out the current mouse position. What this does is this basically means that this value, as soon as we click the mouse button, will be 0, and as we start to drag the mouse, only then will it increase. So we'll just subtract the given mouse position, which means it's kind of like grabbing the vector relative to the mouse position. We will get the length of that vector with a vector length node, not select. Let me just type length. Sometimes I just want Unreal to know what I'm thinking. All right, and then we're going to take that and test it to see if it is less than a certain amount. So we'll do less than float, and let's say 0.2, which would be about what, 20% of screen space? Actually, it should be really, really tiny. But this may be one of those values you want to tweak. So what I would do is I would set it to 0.2, immediately right-click on it, promote it to a variable, and we'll call this the drag threshold. That way, if you find that the game is a little too sensitive, you want a little more play room to figure out whether or not you're dragging or not, you can just tweak this value. So we'll plug this into our condition. So now as soon as the mouse button comes up, we should be able to do some math and figure out whether the player just put their finger down and pulled it up, or clicked and then released and didn't move, versus clicking and dragging and starting to move the cursor around. Because if they did move, then we want to start rotating the puzzle. Okay, so now that we've got that in, how are we going to rotate the puzzle? Well, I'm going to cheat. Rotation math, especially Euler math, and deciding whether or not you can use Eulers or radians or quaternions or any fun stuff like that. It's really fun to figure out, and quaternions are not especially exciting to do in Blueprint, so I'm going to cheat like crazy to get this to work. Here's the first stage of my cheat. First, let's compile and save what we got. We're going to step out and grab our puzzle ball mesh. And let me put it up here so the screen's nice and big. We're going to take its collision, whatever it might have, and we're going to remove it. Next, we're going to add simple sphere collision, or sphere simplified collision, whatever order in which those words make you happy. Now, typically, this would just work. However, I'll give you a spoiler for later on down the line. When we add buttons to this puzzle, all of those buttons have their own collision. And when you have an object that has collision surfaces that are overlapping each other and you force them to overlap, Unreal tries to separate them. And if we don't let them separate, then the whole thing starts to jitter and go crazy. So remember I said that, because if you're ever building something like this on your own and your puzzle starts to jitter out and kind of go mad, you'll at least have heard somebody said that could happen. So I'm going to go to wireframe mode. We'll select this collision, and I'm just going to scale it down really tiny. It's going to be like the size of a golf ball right in the middle of our puzzle. And why on earth would we do that? Well, if this thing has a collision surface, then we can apply physics operations to it. Operations like torque, also referred to among scientific circles as twisty force. So let's save that. We'll go ahead and close this window. So now that we've done that, we could grab our puzzle ball body, and we could say, add torque. I tried typing add twisty force in there and it got me nowhere, which was pretty sad. Now here's where things start to get a little iffy. And this, if you've ever heard me talk about blueprints, you're gonna be like, Zach, I thought you said never to ever, ever, ever do this, but I'm gonna do it anyway. We're gonna use tick. On top of that, we're gonna be using tick to make a physics calculation. These are two things in Blueprint you should, one, try to avoid, and then two, never do, or try to never ever do. But I want to reiterate that we went into this on the principle of prototyping this game. Now this game is going to be perfectly functional. It's so light, so simple, that performance is probably not going to be an issue. Keep that kind of thing in mind, right? If you're ever trying to make the decisions whether or not to use tick or use a high performance sort of function, make sure you're thinking about your game as a whole. Like, even if you're using a very slow function, if your game only needs it once, or if your game isn't doing too much else, that can still be okay, because at the end of the day, you have a perfectly functional game. So just be aware of that kind of thing. So what we want to do is we want to bring in tick. And some part of you wants to just like grab tick and plug it in here, but of course that's not going to be super useful. So what we're going to do is we're going to gate tick. If you're unfamiliar with gates, what they do is they take an incoming data stream, which goes into the enter pin, and it either opens up the floodgate so that that data can pass through, or it closes it off so that the data no longer passes through it at all. By putting a gate on tick, we can determine whether or not we're going to do anything on tick, yes or no. Now the way we're going to set this up is well actually let's back up a little bit. Somebody touches their mouse button or they touch the screen, we're going to record their position, and then we're immediately going to open the gate. And what the gate is going to do is when data passes through it, it's going to apply some amount of torque. We don't yet know how much torque. We don't know the vector for that. We're going to get to that. Next, they release the mouse button at some point. We've determined whether or not they dragged or if they clicked. Now, if this turns out true, basically if the vector length of their drag was less than the click threshold, then Actually, I'll show you one of my tricks. I do this a lot. You might have seen it before. See it again. Grab a reroute node and leave yourself a note on it. They clicked. So if this wire executes, we know that they clicked the mouse and weren't dragging. So what are we going to do then? Well, we're going to do a couple of things. And whenever you have to do a couple of things, you should think sequence. Actually, n number of things. Anything more than one thing. And we'll give ourselves a little bit of space. So if they clicked the mouse, the first thing we're going to do is close the gate back off, because we don't want to add any torque to the puzzle if all they did was click. Next, let's do it. Leave ourselves another note. Stick a reroute node down here. Right click on it. Thank you, reroute node. Aha! And we'll say manipulate puzzle buttons. And that's something that we will deal with later. Right now, all we care about is the motion of the puzzle. So the other thing we need to test for is, what if this turns out to be false? What if the drag threshold ended up being greater than, right? So maybe they actually did drag. But at this point, they've still released the mouse or they've pulled their finger off. So we just need to close the gate. Does that make sense? Hopefully, yes. Okay, so just a real quick step through. We touch, we record that position. We use that position to figure out how far we drag the mouse. If it's really, really tiny, then all we did was click, in which case we close the gate, stop calculating tick, and then we'll manipulate the buttons in some way. If we did drag the mouse, then we're going to let the puzzle spin for as long as the mouse was down, and as soon as they let their finger off, then we'll close that gate, which will stop applying torque. Now the question comes in, how much torque and in what direction are we applying? Well, this is where some of the math that we set up earlier gets to be really, really handy. So to make this happen, all we need to do is grab this vector that we just made from our mouse position, and we're going to break it apart. And I'll be dead honest, the only reason we're breaking this apart is because the vector that we just made is not compatible with applying torque in the direction that we're looking. You could, if you wanted to, just take this vector and plug it directly into add torque, and bad things will happen. In fact, let's take just a minute and show rather than tell. So back over here, let's go over to our puzzle body. We want it to simulate physics. We want to make sure that it doesn't spin like crazy, so we're going to add some angular damping to it. I don't care about linear damping, we're not letting it move anyway. But angular damping can be 5. Then, this is important. If you mess this up, then your puzzle will look really, really funny. Make sure you lock position in X, Y, and Z. If you don't do that, the moment you hit play, your ball's just going to fall down into oblivion, which is no fun for anybody. So with those things in place, we should have something that should start to work. Now let's see, if I just take our outgoing vector and plug it into torque, cross your fingers, ladies and gents. Hopefully this does something. We click and drag. Oh, look at that. It's starting to move the puzzle. But it's moving in a very tiny amount, and it's moving in totally the wrong direction. Watch very closely my mouse cursor right now. We'll start in the upper left corner, and I'll drag diagonally down, and we get this really weird rotation. That is not useful at all. So upon realizing this, when I was building through this game, I realized that our axes as they are don't really work for the angle of the camera. If we were playing this game from directly above, I think they would work just fine. What we're going to do, though, is we're going to swizzle some of the axes around. So let's make another vector such that X is actually going to go into the Z axis, and Y still goes into Y. The new X can just be 0. We don't really care about that. Next, remember how our puzzle was moving really, really slowly? Well, we can make it go faster if we multiply the vector by some factor. So I'm going to set it to 20, and this won't work, but I'll show you why it won't work before we go on. So we'll plug this into torque, we'll compile, we'll save, we'll jump back to our game, we'll hit the magic play button, and now it's kind of working, but it's actually not, and here's why. Look, if I drag to the left, we're spinning the wrong way. If I drag down, we're spinning in the right way. But it makes everything look kind of weird that it's flipped around. So let's take our scalar value, stop playing. Let's set this to -20 and see what happens. Again, just full transparency, because I am not a reigning king of vector math. A lot of this stuff I figure out by way of trial and error. And it looks like what I actually need to do is flip one axis and not both of them, which is fine. That works for me. So let's set this back to 20. And if I recall, I think I was fine in X, but not Y. I should probably double check to make sure. So let's see. X is reversed. Oh, and Y is reversed. They're both reversed right now. I feel like they weren't just a second ago. That's okay. This is where things start to get really fun for everyone involved, especially me. All right. That looks good. That also looks good. All right. It is now dragging in the directions that I want it to. So I just reversed my number. So there we go. I click, I drag, and the puzzle rotates accordingly. And it's just going to continue to rotate as long as I hold the mouse button down. As soon as I let go, it slides to a stop. And I kind of like that slow down factor. It feels really nice and smooth. It actually kind of begs for a sound effect. Like you kind of want to hear like a rumbly whoosh as it starts to roll. That'd be awesome. All right, so let's close this. We should be all good to go. Let's throw in some comments so that we don't lose track of what we're doing later. So we can slide this back out of the way. Some of these comments I'll abbreviate. So let's see. So figure out how far the mouse was dragged, if at all. It might not be. And then convert mouse vector for, I'll do it, for twisty force. There we go. All the physics majors in the room are quietly sobbing in the corner, but I call that a job well done. Okay, so our puzzle is moving. That's awesome. That brings us to our next thing, which is getting our buttons set up. How am I looking on time? How did that go? Wow, half an hour to get that much done. Okay, so let's see. For the buttons, what we're going to do is build a parent class that will define all the functionality of a single button. And then all the buttons that will be in our game will be child blueprints of that parent. So we're going to spend most of our time just worrying about setting up this parent class, and then we'll create a bunch of children classes and set some of their values. Now, it was asked really early on by somebody here at Epic why I'm going to have multiple child classes of this parent. If that question doesn't make sense to you, that's fine. For the folks who grok that, that's cool. Just hear me out. So you could have one child class that had a parameter that allowed you to change out which mesh you're using and what the ID of each button is. That's certainly viable. However, we're going to be using child actor components. And as you will see, when we add a child actor component into our blueprint, we do not have access to any parameters that we were to set up on that blueprint parent class. So it's actually easier for us to set up multiple children all at the sibling level in the hierarchy and just assign each one of those as individual child actor components. If that didn't make sense to you, don't worry, I'm about to demonstrate it anyway. So, moving on, let's create a new blueprint class. We're going to base this off of actor, and we'll call this ball puzzle button and then underscore parent. Just the underscore parent is just there to call out the fact that this is a parent class. Some people also call this base class. Either one is valid, just whichever one makes you more comfortable. Now let's double click and open this up, and we need to set up some of the base properties here, one of which is that it needs the button mesh. And it doesn't matter which one we grab. For simplicity's sake, I'm just going to grab button 01 and drag it in. We need one of those. Also, wouldn't mind pointing out all of these buttons have a collision surface on them. That'll be a little important to know later because we're going to use that for something else that we're going to kind of cheat on. Okay, so we're going to add some variables to this, some things that we know we will care about at some point along in our puzzle. So we'll add, so let me make this nice and big so everybody can see it all. We'll add a Boolean variable that we're going to call button state. And we're going to make sure, actually I don't think we have to do anything special with that. I think it's fine as it is. So we'll compile that. It's set to false by default, which is great. Next, let's add another variable. We're going to call this button ID. This really will not be useful until we set up a UI for these. And once we set up that UI, this is just going to be a shortcut for later on down the road. So if you were building something like this on your own from scratch, it actually makes sense to me if you didn't know you needed an ID and you found out you needed it later. The nice thing is it's really easy to add in the parent class, and then suddenly all of your children just magically get it. We're going to cut some time off, though, and go ahead and have it already here and set up. Next, now this is where things get a little bit fun. We're going to add a variable called button mesh. And this will be of type static mesh, specifically a static mesh reference. Now if I compile this, I can now change what mesh goes inside this variable, and we're going to set this to button 01. The reason I'm doing this is that this will be a value that we can change to make sure that each of the child blueprints of this have a different version of the button as their mesh. Because I exported out 12 individually spaced and located buttons that all had their precise locations from the origin when I pulled this out of Maya. Okay, so let's go ahead and save real quick. The first thing I want to do in terms of functionality is set up the construction script. This is pretty easy. We can grab our button mesh, we get a reference to it, we drag a wire out from it, and then we say, oh my god, what the hell do we say? We say set mesh. And you should see set static mesh for the puzzle ball. Aha! I'm not trying to drag a wire. Work with me. Thank you. Excellent. So cool. First thing we're going to do is we're going to take whatever is inside button mesh and we're going to assign that to be the static mesh for the puzzle ball. That way, if I set button mesh to be one of the other buttons, then we'll just magically get that button instead. Next, we are going to take whatever material is currently applied to our puzzle ball, and we're going to create a dynamic material instance for it. We had to do this because the materials for those buttons are changing at runtime. They're going from dim to lit, like we demonstrated early on in the live stream. And then just to be on the safe side, let's take our return value from this. We're going to promote it to a variable that I will call dynamat, which is kind of what I always call my dynamic materials if I only ever have one of them. And there we go. Super simple construction script. Just set up the mesh, set up the material, and then we are ready to go. Now we are ready to start building up the actual button functionality. Now there are three things this button needs to be responsible for doing. One is it needs to change its own state to on or off, and whether it's lit up or not. Next, it needs to change the states of the 5 buttons around it. So it's going to have to reach out and say, hey, what buttons are near me? Oh, you 5? All right, you, and you. However many U's that was. Make sure all of you guys update your states as well. Then we're going to add another one just to make our lives easier down the road. Maybe your life more than mine because I've done this a couple times now. We're going to force the buttons to each draw their own ID number on the screen so that we can... now this is just a debug feature. We're not going to leave it on as part of the game. That'd be an entirely separate thing. This is just so that as we're setting up the UI and other parts of the game, we can hit a button and see which numbers correspond with which buttons. Just make our lives easier later. So let's start by setting up changing our own state. Now the first initial events that come in here, I'm going to remove. I'll add them in later if I feel like I need them. We're going to begin with a custom event. Custom event. We're going to call it toggle button or something, some word like that. Toggle button state, like so. Awesome. Now what does this do? Well, it's going to take the current button state, whatever it is, and whatever it happens to be right now, we're going to make it not that. I actually love that node. I wish there was a not node for more things in my everyday life. Next, we are going to set whatever the result of that is to our new button state. So that already does the toggle. That takes whatever our state variable was and just flips it to the other thing. Next, though, we need to update our material. So let's grab a reference to our dynamat. We'll drag a wire out from it. And we will say set scalar parameter. Now earlier on I showed you the inside of the material and that had a parameter named state. We did that off camera. You didn't get to see it, but it did save us a little bit of time. So we're going to take our state parameter and set it to a new value. And what value is that? Well, we're going to cheat once again. We're going to take whatever the output is of this not node and just plug it right into our value. Now you'll notice that value is expecting a float. So if you try to connect this, Unreal basically says, oh, I get it. You have no idea what data types are. Let me just fix that for you. And it creates a nice little conversion node for you. So that actually is all we really need to do in order to set up the changing of state. We just have this single function called toggle button state. Now, I've had folks ask before if you wanted to, you could have made this a regular function instead of a custom event. There's really no difference one way or the other. It's just the way in which you like to work. Generally, not often, and actually not even in this project, but when I'm on bigger projects, I will try to reserve functions for something that requires a return value, but I don't even stick to that rule all the time. I'm not even going to be sticking to it today, but that's just something for you to chew on. Okay, so now we've got our buttons, or at least that first thing they need to do, which is change their own state. We got that done. So let's go over to our pawn, and let's get all of these buttons set up on our puzzle proper. So we'll do that by adding a child actor component. Now, as soon as that comes in, I'm going to do a couple of things. First, we're going to name it. Naming is important. We're going to call it button_1. You probably should do 0, 1. You should pad out your number to the number of digits that you have, which that goes up to 2 digits because our highest number is 12. It's just a good practice. I'm going to drag that and parent it to the puzzle ball body. Why? Because the body's rotating around and I want the buttons to go along with it. Now next, with the child actor selected, come over here to its properties and under the child actor class, what are you going to choose? Well, you don't have what you want right now, so this is only part 1. Let's compile, save, and we'll leave this parked right here. Next, over here in our content browser, we need to make a bunch of child actors. Or child actor blueprints to be specific. So I'm going to select my parent, my button parent class. We'll right click, and at the very top you should see create child blueprint class. We'll call this button_01. Now, because I don't want this folder to get super cluttered, and there are schools as to whether or not this is a grand idea, I'll leave that to you and your programmers. I'm going to add a new folder, which I will call child blueprints. I guess I could also call it buttons, but I'll call it what I called it. I'm going to drag this into this folder and choose move. So all of my children's are located here inside of this folder. Now with that done, I can hit Control W and duplicate that and check it out. I automatically get button 02. So let's just duplicate them all off. So click, Control W. You will have to probably deselect it. There you go. And then reselect it in order to get the duplication to work. Also, if you notice a little bit of a lag in when you create the duplicate and when it actually appears, that's just some loading time. Don't stress that. Button 8. There you go. Button 9. Hello. Button number 10. And notice that the content browser doesn't know how to count sometimes. We'll run into that a few times. You'll just have to keep it straight in your head. Just notice it starts with 10 and 11. A lot of computer programs do this. If we wanted to avoid that, we would have padded out another layer, but we didn't. So I have 12 buttons, but they all have the exact same properties. Now it's time to fix that. So I'm going to close off whatever classes I'm not using. You'll see why in a minute, because we're going to have to open up all 12 of our classes. Actually, I should probably leave that in a floating window. It'll probably make my life a lot easier. So number 2, number 3, 4, and so on. Just open them all up. Okay, now we're just going to go row by row and change some values. So here we are at button 1. And if we go over to its class defaults, all we need to change is this button mesh. Now this is currently defaulting to button 1, so this one's fine. We're going to take button ID though, and we're going to set that to 1. You guessed it. Now I got to do this like 11 more times, but the good news is, starting at number 2, I just have the properties window, so it goes a little bit faster. So bear with me, play some Jeopardy music or something while I get all these set up, but you kind of follow, right? Here we are at button 3, we'll set the mesh to the mesh for button 3, we'll set the ID value to 3, and rinse repeat. It's a little tedious for sure, but I assure you it's nowhere near as tedious as it would be to figure all of this stuff out in your blueprint script. So we're actually saving ourselves a lot of time right now. Go with 6. Oh, and then for those of you who play with code, or you're more of the programmer types, you're thinking, why is his number of buttons not 0 based? Mostly that's just there to irritate those of you out there who feel that way. I tend to think in counting numbers, so I'm It's probably the art side of my head. I tend not to think of 0 as the first number, and I'll admit, if I did think that way, it would make some of the things we're going to do later on just a little bit easier, but it's nothing we can't work around. If you were to hand this final puzzle off to a programmer and say, hey, take this great game that I did and make it into a C++ game, they might make your list 0 based, but I would leave that to them. And without name dropping, I can think of a couple of programmer types who are probably like, they're going to watch this at some point and be like, oh my god, it's not 0 based. All right, so that's all of our properties set. Again, all we did was set the appropriate ID number and the appropriate mesh for all 12 of our child actor components, or I'm sorry, child blueprints, which will in turn become child actor components. For now, let's just close all these out. Then make sure you hit Control S to commit all those changes because you got to save a lot of things at once. And then we will go right back into our pawn. Awesome. Now here we had our first child actor component in place, and now you can see we have button 1. If I come over to the viewport, you can see that our first button just appeared on our puzzle, and I just accidentally moved it, so we don't want to do that. Okay, so now let's add a bunch more buttons. I can just select this child actor component, hit Control W, and name it button 02. And then come over and change its number. Now because of the way I like to work, I'm just going to do this one operation at a time. So we will add, actually that should be 03. Make sure I pad my values, or at least remain consistent if I'm going to do it some way. So Control W, let's go ahead and add 4. And button 6. Button 7 or 78, because typing is apparently a thing. Button 08. Is this as boring as I think it would be? I feel like this would be like mega boring. Like if you could fast forward the stream, this would be the time to do it. Once you figure out how to do that though, that means you ripped apart the space-time continuum and send me an email, tell me how you did it. Because we're gonna get rich. You and me. And then button underscore 12. Okay, cool. There's all of our buttons. Now we do need to set up all of their appropriate meshes. We already did that with button 2, so let's take number 3 and set it to 3, and 4 and set it to 4, and so on and so forth. What is this, number 6? I'm already losing count. That's why this is important. Get it out of the way soon in an avenue that is easy to double check. Also, the screen in which I'm doing this is like 7 miles away right now, so I'm having to use my incredible eyesight to make out what the heck is going on the screen over there. But don't worry, I've got you covered. All right. So my eyes aren't that good, hence the glasses. All right, last 2. Number 11. And then last one, number 12. All right, awesome. There's everything. And the cool thing is now, when we hit play, we gotta give it a sec. It's recompiling all of those child blueprints. We're zoomed in like crazy right now. But we can see all of our buttons, which is pretty excellent when you think about it. Now, I do need to apparently adjust the distance to the camera, so let's fix that real quick. Let me make this window just a little bit bigger. You can tell I'm used to working on 2 monitors when I'm just doing my thing. So let's see. Let's get a copy of this in our view. And we just need to figure out, we need that picture-in-picture view. There we go, that'll do. Looks like I probably need to slide it out just a little bit further than it is. We'll guesstimate. You can always tweak it later. Or if you were really, really fancy, you could use like the mouse wheel or something to add a zoom factor in your game, which we are definitely not going to do. But we can hit play now. Cool. I can see the whole puzzle. Awesome. So our buttons are in place. They have some functionality, but right now that doesn't matter because we're not using that functionality, and we need to be. And this is where things start to get a little bit fun because, let me close this for now. We'll get back to it. And I'm going to hit Control S in case something catastrophic happens. Because you have the option of using click events on your player controller. You might have seen this before. If we open up the player controller, we have enable click events. That's cool. You can actually use these and make your buttons respond. However, I want the ability to break out the result of that click trace. So we're going to kind of roll our own, and we're not actually going to use click events from the player controller. We're going to build our own system to handle that. And we're going to do it here inside the pawn. Now earlier, as a quick reminder, we had touch. We gauged whether or not they were clicking or dragging. And then we had our little switch here. And if it was true, they clicked. And if it was false, they were dragging. Well, let's focus on this part. So they clicked apparently. First thing we do is close the gate so we're not moving the puzzle around anymore. And then we need to manipulate the puzzle buttons in some way. Well, here's how we're going to do that. First, we're going to perform a trace. And that trace is going to result in us hitting one of the buttons. We will figure out what button we just hit, and then we will call toggle state on that particular button. And here's how we're going to do all that. Way back here, we got the player controller. So here it is, way back in this location. We're going to grab a reference to that. Now, if you wanted to, you could get controller and cast a puzzle PC one more time if you really wanted to. Or you can drag a really long wire. It's a philosophical question, and whichever one makes you happier. What I will do, I'll do both. It depends on my mood. But more often than not, I will drag out a really long wire like this and add a reroute node. And then just throw a comment on the reroute node for later so I don't get too confused. I can be like, all right, here we could be really funny. You do an arrow and say, to player controller. Like it's a road sign or something. And so that goes all the way back to the player controller. So now we're going to take this and we're going to say, convert mouse location to world space. So mouse location to world space. This is a really fun node. This does exactly what it says. It takes whatever the location your mouse was and gives you the world coordinates for that. Now using that, we can figure out how to run a trace. So let's go ahead and set up a trace. We're going to do a line trace by channel. If you are unfamiliar with the concepts of trace, basically it's a laser that is fired over a single frame, and then whatever it hits, we get some data that we can query. For example, we can ask it, hey, what actor did we hit? What was the normal that we hit, like the angle of the surface where we hit, and all kinds of stuff. By the way, if you saw all that stuff magically appear, that's because I used the split struct pin option. I just right-clicked on out hit and chose split struct pin, which I'll do again later. So for now, what we're going to do is take this new world space location for our mouse. We'll take the world location and let that be the start of our trace. And then we're going to do something kind of fancy. We will take the world direction, which is a normalized vector, which means it has a length of only 1, and we're going to multiply that by a number. And that number will be, let's start with something really high. Later on, you might want to lower this value so you can't click through your puzzle, but I'll let you deal with that on your own. We're going to set this really high, like 10,000. And then we will add this to our current world location. So we'll combine these together, and that will become the endpoint from our trace. Now the upshot of this tiny little network, and you should remember what I just built, and you should keep it in your back pocket, because it's a super useful trick whenever you're building a game that has mouse controls. This fires a trace from the location of the camera through the mouse cursor and on out 10,000 units. So that's super useful. You can use that for all kinds of things. So that should just be working, hopefully. We could test it, but for the sake of time, actually not gonna. We're going to take our out hit. Let's split it apart so we can see all the different bits and bobs of it. Let's take the actor that we hit and let's cast that to a button. And this is where things start to get really specific. First off, as a reminder, casting is just a way to verify what it is you're talking to. In this case, we know that we hit an actor. At some point, this trace is going to hit an actor. And we're saying, hey, whatever actor you hit, make sure that it is a button. But which button do we cast to? It would be easy, if you're a beginner to all of this, to think, well, let's cast it to button 1, and if that fails, we'll cast it to button 2, and if that fails, we'll cast it to button 3. I've actually seen that a lot, and I've seen it more than once from people who worked at big studios, so it's a very easy misconception. However, we can use the class hierarchy to make this easy. We can cast to the parent class, because every single child class, every single one of those little buttons we just made, is also the child class. That's the way inheritance works. So we'll cast it to the parent, and if it is the parent, we will call toggle button state on that thing, whatever it is we just hit. Now with all that, let's test it. Let's make sure it works. Cross your fingers, hope I didn't break anything. Oh, check it out. I click. And it feels a little... Oh, do you know what it is? So like I was getting bad responses there. It's because my hands are a little shaky or something, and it actually thought that I was moving the puzzle. So you gotta hold your hand really, really steady. If that got to be problematic, you might want to increase that drag threshold slightly to solve it. For now, I'm just gonna hold my hand still. But we are getting the ability to toggle our buttons on and off. That is the first part of our button functionality. Good job, students. All right, so we're 1 hour in. Let's go ahead and close this window. Let's throw a comment in here. So we will trace and call toggle state on the button we hit. Which you didn't see any of that appear, but it's there because I was staring at my fingers while I was typing, which is a bad habit, but it really increases my accuracy. Which is also why I'm never gonna be a programmer. Okay, so the next thing our button needs to be able to do is toggle the state of all 5 buttons that are around it. Now we're going to set up that functionality inside the button parent itself. So let's go back over here into that class. Let's put a comment around this. Toggle my own state, because this is the button talking about himself. All right, next we want to toggle the state of the surrounding buttons. Let's do this with another custom event, or at least that's where we're going to start. Also, the use of custom events here does mean it'll be a little bit easier to read later on because we can just put them all side by side. Let's call this toggle surrounding buttons. Okay, now how is this going to work? Well, this is going to need to do some sort of a reach out. It's going to, like the button is going to say, okay, which buttons are nearest to me? And if I can reach out and touch those buttons, then let's adjust their states as well. And how do you do that? Well, we can do that with a sphere trace. A sphere trace is just going to take a sphere and pop it into existence. Technically, it's going to sweep the sphere and move it, but we're not going to let it move very far. So we're just going to have this tiny little sphere that will magically appear, and whatever other buttons that sphere touches, we can just call toggle state on those buttons using the existing functionality we already have, and everything should, cross fingers, just work. I cross my fingers a lot. It's like I doubt that all of this is going to work. Don't worry, that's only because I'm the one building it. So, next, here's where things get a little bit tricky and where I'm doing a couple more cheats. A long time ago, I mentioned that all of these button meshes had collision. Now, if I'm just doing traces, and those traces are just using the visibility channel to figure out whether or not we hit them, I technically do not need those collisions. So why do I have them? Here's why. I can use this to my advantage in the following way. If I need to know where the center of the button is, I can grab that mesh, and I can say center of mass, and I can get the center of mass, which will be the center of that collision volume. Totally a cheat, might even have a somewhat slight effect on performance, but again, with a game this simple, it hardly matters. It does mean, however, that I don't have to figure out any sort of special mathematical vector for where the actual button mesh should be positioned in 3D space. There's a lot of different ways to do this. This was just a really fast and easy one, and sometimes I like fast and easy. So we won't read into that. Next, let's create a sphere trace. So we have a multi-sphere trace by channel. Now, why are we using multi-sphere? Multi-sphere means we could have multiple output hit results. So we're going to have this one sphere that could potentially hit lots of different things. We need that because we need it to hit 5 buttons. And here's how we're going to roll with this. First, we will take that center of mass location and use that as the starting point of our trace. Now, it is super easy to think that that could be the start and the end, and that would make a lot of sense from a practical point of view. However, this is the trace itself is going to sweep this sphere through the world, and it has to have some distance to sweep the sphere. If we set these to the same distance, there's no sweep amount, meaning the trace won't happen. So if you ever tried to use this, and you used the same value for start and end and got nothing, that was your problem. So what we'll do is we will add a vector to a vector, and we'll plug the result into the end, and then I'm just going to take, it doesn't even matter what value, like even z, and we'll set this to like 0.1, some tiny little value, which means almost nothing. Then we're going to take the radius, and I'm going to set it to 40. That is totally a magic number that I got by trial and error of figuring out at what point I was touching all the buttons. If you needed to do that on your own, just turn on the debug type for a duration, and you can see how big the sphere is in the viewport when you call it. And you can just adjust the radius until things start to hit. So this should be calling our trace. At this point, we manifested a sphere. It went pop, and it should now overlap all 5 of the buttons surrounding us. We should be ignoring ourself in this trace, meaning that this button gets left out, which is good. That's what we want. Next, we need to take all of our hit results, all the things that we hit, and we're going to do a for each node or for each loop. This is going to loop through all of them and do something to each thing that it finds. And what are we going to do? Well, we're going to first split this struct pin apart. We're going to take each actor that we hit, we are going to cast it to a button. It's just like before, cast it to a button parent. And on that, we will simply call toggle button state. So do you see what this is doing? All we're doing is saying, take the button that we just called this on, grab its center of mass, do a sphere trace, like a radial trace around it. Everything that overlaps with, call toggle state on those as well. So let's go ahead and let's put a comment on this. Toggle surrounding buttons. All right, wicked and awesome. Let's compile, let's save, and let's play, see what happens. So I click on a button. Oh, it's not working. Well, of course it's not working. I never called it. Good Lord. Okay, so meanwhile, back over here in the pawn, here's all that I was missing. This is actually kind of embarrassing. So we drag over here. Remember, we called the button state of the thing we clicked on. That's why our puzzle works. Let's just grab that reference once again. And we will also call toggle surrounding buttons. Call one after the other. And to make it a little easier to see, I'll stick one reroute node in here just to move the wire around. So you can see what that's doing. All right, now let's test, this time with a little bit more failure, or less failure, I think is what I meant to say. And there you go. We are toggling the state of what we click on and the state of all the buttons around it. Looks like that worked. I thought I noticed an error in there, so I might want to tweak out the actual radius of the sphere trace. But currently, it seems to be working. Okay, so we have the functionality for our puzzle. So what do we do now? Well, there's one more thing that I said our buttons needed to do. They need to be able to change their own state, change the state of the buttons around them. We have those done. The third thing was draw debug numbers on themselves. Now, this takes a little bit of setup. This is not something we can do in just a single class. So let's go ahead and jump in. We are going to start this off here inside the button itself. So let's go into the button parent class. Start down here at the bottom. And again, I'm going to do something that you normally wouldn't do, but since this is for debugging purposes, I don't feel too bad about it. We're going to make use of tick. But just as before, we are going to gate it. So most of the time, we won't be doing anything with tick. Sometimes the tick execution will pass through, and then what are we going to do when that happens? Well, we're going to take this button mesh, because each button is going to call this on itself. So each button mesh will get its own center of mass. And at that location, it is going to draw a debug string. Now we're going to leave the duration at 0 because this is going to be called on every single tick. The reason we do that is so that as the ball rotates around, all of the numbers will rotate around with it. If we left them for a duration, you'd get some weird ghosting kind of effect, so we're not going to do that. Now, the location can just be the center of mass. That's super easy, but what text we're going to feed in? Well, this is one of the first parts where button ID is going to start coming in handy. So we can just feed button ID in like so. There you go. A quick note, this is one of those little pet peevey things you should know of. If you try to drag this button ID straight over to text, it tells you no. So make sure you drag it in and get a getter and then connect it, and then it'll give you the conversion node. Just remember little things like that. They'll save you some frustration. Okay, so we can save this and compile, but right now it's not going to do anything. What we want, as this continues to compile, the reason it's taking a minute is it has to compile for all 12 of our child actors. Now, how do we turn this on and off? Normally I use open and close, but in this case we're going to do a custom event that I will call draw. Actually, let's do toggle. Toggle debug numbers. And we're going to connect this to toggle. Now it'll turn it on or turn it off. Whatever state it happens to be on, it'll just switch it over to the opposite. Now, who's going to be responsible for calling toggle debug numbers? This is where things start to get a little more complicated, and I could sit down and probably have discussions with folks over whether or not this should be in the game mode or the game state. And I'm sure that there are those who would staunchly feel it should be in the game state, because it's kind of an activity we're performing on the game, and the game mode should really just be for the rule book. This is one of those cases where the game is so simple that it almost doesn't matter. But I'm going to go ahead and throw in game state, mostly just to get you used to the idea of using game state. So think of your game mode as just kind of a mass rule book for how the game should perform. The game state should be the state that the game is currently in. So like what's your current score, how, in this case, how many buttons are actually lit. And then we're going to hide a lot of our debug functionality inside the game state. But again, totally philosophical. Neither one is necessarily correct or incorrect because they're both going to work just fine. So we need a game state. I'm going to right click and make a new blueprint class. We have to dig for game state, so expand all classes. Search for game state. And there it is right there. Click. Select. And we'll call this ball puzzle game state. Immediately jump into your game mode. Actually, I should have put GS instead of games, but whatever. In fact, I think I'll rename it. Let's do that. Make sure I'm consistent. Consistency's good. Let's grab you. Delete. Awesome. So GS. Open up game mode though, GM, and make sure at the bottom you take the game state class and set that to your new puzzle game state. That's just going to bring one of these into the world for you to use later. So now, let's open up the game state. Now, I want the game state to be responsible for knowing how many buttons exist in our puzzle. I don't want the game mode to care about that, because the game mode shouldn't care. The game mode is just like, hey, however many buttons you have, this is how the game should work. That opens the path later on for you to have multiple game types that have different numbers of buttons on the puzzle. So we need to feed the number of buttons up to the game state in some way, and here's how I'm going to do it. Here inside the game state, let me bring this up to the top so everything's nice and big. We're going to add a variable, and we will call this the button list, like so. And then we'll set its type to button, and we'll choose button ball puzzle button parent. We'll click that, and we'll compile. This is just going to be a list of all the buttons, but we are not going to populate it here. We're going to populate it from the pawn. The pawn knows how many buttons are there because the pawn actually has all those buttons assigned to it as child actor components. So let's find a nice blank spot up here above our graph in our pawn. And on begin play, we're going to do some initialization stuff. We're going to grab the total number of buttons, and we are going to send that off to the game state. And here's how we're going to do that. First off, grab button 1 and just drag it in. Then we're going to make an array of these. Then we're going to add a whole lot of pins. So add 1 pin for every single one of your buttons. Again, notice this is a zero-based list, so this is where all the programmers get to be smug for a minute. So let's just plug button 2, button 3, and 4, and 5, and 6, and so on and so forth. Oh, I think I skipped one. Where did button 8? Oh, I reparented button 8. Do not do that. I'm okay if this list is out of order, but they all kind of need to be there. Button 10, button 11, and button the 12th. Okay, and then if you're like me and this really weird kind of overlapping arrangement of the nodes gets to you, then you can take just a second and clean that up. Cool. So there's all of our buttons stored into an array. Next, we're going to do something that is kind of fun. We're going to perform a for each loop on all these. This is going to cycle through this list of buttons that we just made. And for each one of these, we are going to say, get the child actor class. So basically, what actor did we assign to this child actor component? That's going to be important. As a double check, we're going to cast this to a button parent, because it's not going to be a button parent at first. Remember, it's going to be the actual child class itself. So we're going to cast it over to verify that it is, in fact, a button parent, or the parent class. And then as a button parent, excuse me, we are going to make a brand new variable, and we'll call it, same as before, we'll call it a button list, but this is the one that lives over in the pawn. And we'll set its type to a button parent, just like we did before. And we'll make it an array. Also, I need to verify over in the game state. Did I make that an array? I don't think I did. So over in the game state, double check, make sure that's an array, compile and save, because you don't want to mess that up. Over here it's an array as well. That's good. Let's compile. Now we can grab this button list, get a getter reference to it, get a reference, and then drag a wire out, and we're going to add, actually, I'm sorry, let's take the result of our cast. We're going to add unique and add this into this array. Now, what did I just do? What was all of that? So at the beginning of the game, grab all of these child actor components, each of which is a child blueprint. So just grab them all, put them in a temporary array, and then run a loop on them. For each one of them, figure out what their child actor was and get the parent class. Make sure that it is a button parent class. After you do that, store it in a separate array that is in a variable, something we are actually storing and recording. Once we've done all of that, we can now pass this onto the game state. So we can say get game state, and we have to cast this. We have to make sure that it is the ball puzzle game state, otherwise we won't get access to it. I can't imagine this being any other game state, so I'm going to convert that to a pure cast. And then we are going to set button list. So that sends that up to the game state. So now the game state is aware of all of the different buttons that we have, which is awesome. Okay, let me double check everything here. I think this is looking pretty good. Turns out, well, we could have probably just done this directly to, well, like we didn't actually need to store this array here. I'm just doing it for safekeeping in case I need it later. I probably won't, but this is fine. So let's drag a box around this. Let's comment it and say, send list of buttons up to the game state. There we go. So now that we've done that, let's compile and save, and let's go back over to the game state. So now, when we're playing the game, this button list should be populated, which is awesome. Now, over here in the event graph for our game state, we're going to wipe out the things that we don't need. And we're going to say Let's make a custom event. I keep wanting to just type whatever I feel like in here and have the option to make a custom event for it, but I think I've been complaining about that for probably way too long. So let's do custom event, which we will name draw debug numbers. Awesome. Now let's grab our button list. That's just going to take all of our buttons. Now we can just perform for each loops on this, which is awesome. So we just say for each. All we really want you to do is toggle debug numbers. That's it. That's all you have to do. So the game state is calling that now, but nobody's ever telling the game state to call that. This is where this starts to get a little bit complex. You could argue, well, hang on. You'll argue in a second. I can feel it. What I'm going to do is over here in my pawn, I'm going to set up a D key event for whenever I press D. And all this is going to do is get the game state, cast it over, which I'll make pure once again, mostly because I'm lazy. And this will just simply call draw debug numbers. And you could say, hey, why didn't you just put that in the pawn to begin with? You could. It's one of those things. So the pawn is just responsible for dealing with this incoming input. The game state is responsible for performing this action on the game. So I think actually with all this should be working. Let's compile, save, and test. Let me do a quick double check of our parent. Yes, that's just toggling. All right, let's hit play, see what happens. Oh, look at that. We now have debug numbers that are appearing over all of our buttons. It's easier to see where they are when you rotate, for sure. But this will be really handy when we're trying to figure out what goes where on the UI. With that, our buttons are doing all of the things that they need to do. And we are, oh wow, we're only an hour and 15 in. This is going actually a lot better than I planned. Okay, so now to make the game a little more interesting and playable, we're going to randomize the lights at the very beginning of the game. Now, from my perspective, that's a rule. That's just one of the ways in which the game works. When the game begins, we are going to randomize what buttons are on and which ones are off. So I'm going to do that inside the game mode. Again, though, this is all philosophy. One of those things you might want to discuss with your other developers. All right, so let's jump into the game mode. And right now, we are not in the full blueprint editor. Let's make sure we get there. And on begin play, all we're going to do is grab our list of buttons that we've already built. It's down in the game state, but that's okay. We have access to it. And we're going to randomly set the state of all of our buttons. And there's two ways you can do this. One of which I can guarantee is always solvable. The other one I can't guarantee is always solvable because I haven't actually done the math as to whether or not you can have some pattern of buttons on this puzzle that cannot possibly be solved. I will leave that for you to play with. If you want the game, well actually let me build it just the regular potentially unsolvable way because that's a good way to irritate your friends. And then I'll show you how to transition it over so that it is always going to be guaranteed to be solvable. Here's how we do it. First, let's get the game state. Again, you see I do this a lot. And from this, we're going to have to cast. And again, I'm going to make that a pure cast. And from this, we're going to get the button list. There it is. Now, on our button list, we're just going to run a for each. And on each one of those buttons, we are going to randomly set its state. And here's how we're going to do that. So let's call toggle button state. But we need to determine, are we going to call it or not call it? Basically, are we going to skip that button? And here's how we're going to do that. We will branch, and if true, we'll call. If false, we won't. And then for the condition, we'll just drag a wire out and say random bool. There you go. So now we could compile, we could hit play, and oh, did that even work yet? I don't think it worked. Oh, right. So this has to do with the order in which things spawn in the game. The game state and all of the pawns and everything have not been born the moment this game mode has been added to the world. So you can maybe argue this is a little hacky, but I really don't mind it. We are going to just put a little 0.2 second delay in here. Alternatively, you could make it so that the pawn sends a call up to this as a custom event as soon as it's done building the list. Just to kind of illustrate how that would work. Earlier on, right, we do this loop that builds up our list of buttons and it sends it up to the game state. You could just say on completed, reach up to the game mode and randomize the puzzle if you didn't want to do this delay, if you felt that was hacky. I'm just going to go with it. So compile and play, and it still didn't work. What am I missing? What did I screw up today? So we're calling toggle button state on the button list. Well, let's just debug it. Let's see what happens. If I hit play, well, that didn't even fire. All right, let's save. Let's see, what have I done? What have I done? I'm just digging through my notes. No, the notes look pretty legit. I think we're still okay. Let me just try it the other way. If first you don't succeed, yell at the screen and do it again. So let's make a custom event, which we'll just call randomize lights. We'll plug that in and compile and save, and then I'll just come back over here to the pawn, and after we're done building this list, we will in turn say get the game mode, and we have to cast this as well. So cast this to the puzzle game mode, convert that to a pure cast, so now we should have access to all of its functionality, and let's call randomize lights. Woof. Well, that's less than ideal. Well, let's figure out what's going on here. So, oh, hang on. Let me, let's see. I need to go back into my button. I have to figure this out. This is now going to drive me crazy. So, meanwhile, over here on my button, when we toggle a button state, we should be setting this value, and we should be calling the material update, so that should be good. We are toggling the button state. Random bool, what are the odds that that's just not doing what it should? Hang on. What if we set that to always be true? Then what do we get? Okay, good. So we know that that's just not doing what it should do. Believe it or not, that makes me feel a little better. I'm sure this is something simple. Wait a minute, wait a tick. Hang on. Over here in my game mode. Oh no, I know what this is, and it's so embarrassing. Okay, let's go over here to, or at least I think I know what this is, and if it is this, I'll be super embarrassed. So no, we're using the game mode, so that should all be good. Erg. All right. I want to put this back the way I think it should work. With like a half-second delay, which is like 10 times longer than I should need. This is all going to turn out to be just some stupid little thing that I overlooked. Oh, I think I might know. Hang on. Stop. First off, let's get you out of the game. And then play. Huh. That's really interesting. Okay, so what this tells me is that it's possible that that list of buttons that I sent up might not be populated at all anymore. If that's the case, then I should double check that, and I should make sure that that list is actually getting populated. Now, here's how I would debug this. Let's start off over in the game state. No, let's start off in the pawn. I want to do this in the pawn. So each one of these that we add unique on, let's do a quick print string. And what I'm going to do is grab the result of whatever that class is, that child actor, and I'm going to print that out. to the screen. So now when I compile and play, let's see what we get. Okay, I get this big long list of buttons. That's good. So now we know that that's working. So now let's just move up the chain. Let's go over to the game state where I sent that stuff in the first place. Let's do a begin play. And I'll delay it just to be on the safe side. And what I want to do is grab my button list. And let's for each that. And for each thing we find in the list, let's do another print string. Like so. And we'll connect like so. Actually, we'll connect like so, and then like so. All right, so now let's compile and test this. Cool, so that means the list made it up to the game state just as we'd hoped. Awesome, that means I don't really need this anymore. Cool, now we can come up here to the game mode. So the game mode, at begin play, we're doing a brief delay. Let's move this up here off kind of to the side. We have this little graph which should be grabbing that button list. Let's copy it for a moment. Let's do another for each off that. Let's do another print string. And let's print out that display name one more time. I should see the same results all the way across. Cool. So we know that that list has been populated and we know that the game mode has access to it. Perfect. Now I just need to figure out what's going on here. So we're trying to call toggle button state on each one of these guys. So what happens if I just call toggle button state and that's it? Like I don't worry about any other logic. Let's pull this out of the way real quick. Nothing. Oh, it looks like it might be toggling and not updating, so something just happened. Oh no, okay, it was just in my head. It looked like maybe I clicked and it might have changed the state internally, but it hadn't updated the material, but that wouldn't be right, it wouldn't be good. I wouldn't want that to be the case. Okay, so this is actually pretty curious, so let's do this. Let's make sure that this loop is functioning the way that I want it to. So we can test that with another print string. You see I use these a lot for debugging. They're super useful. Just don't leave them lurking around in your blueprints afterward, or if you do, make sure you turn off their ability to print, because that can be really frustrating for your other team members. Okay, cool. So we do see these. Awesome. And when I'm calling toggle button state, I'm just not getting the result that I want. That tells me it's a problem over in toggle button state. So we'll look at that next. Okay, so the print is still firing, which is great, but toggle button state doesn't seem to be doing what I want it to do. So let's start over there. Let's see if I want to try something. Let's try calling toggle button state, and also let's then call toggle surrounding buttons. Okay. So that turned everything on. So it looks like calling single toggle button state is getting ignored. So real quick, I'm going to do something. Let's go over to my button. I'm going to disconnect toggle surrounding buttons. I'm just going to test the game, make sure this is working the way I think it should be. Now, it's going to take a second to play because I made a change in the base button class. Okay. So this is working just fine. So what could that designate? that means that when I call it in pawn, I wonder if casting is the problem here. It shouldn't be, because our button list should already be of the type that we need, but I'm gonna try it and see what happens. Unreal should yell at me for doing this, but we're gonna try it. Cast to button parent. In fact, if I compile, yeah, okay, it should yell at me. I was hoping that I would see it yell at me. Interesting. So what is their initial state? Their initial state should be false. So I'm not entirely sure why this is happening the way it is. I'll be dead honest with you. But let's do this. Let me see if I can find a way to work around it. If I call that on every single button, what do we get? We also get nothing. But when I called the two together, everything was fine. Did I leave that disconnected? I might have. Nope, I connected it back up. Okay, so what I'm going to do for now is I'm going to step away from this, and I'll come back to it just for the sake of time. We'll go ahead and put together the HUD for the game, the heads-up display. And then once that's done, based on time, I'll come back and kind of revisit what's actually going on here. It's a little weird, but I'm sure I can get to the bottom of it. Real quick, before I jump topics, let me glance and see what kind of questions are starting to pop up. What is actually easier to do? Start your puzzle at the end or start at the beginning in terms of developing a level? I think it depends on what your puzzle actually kind of looks like. If you have a really, really intricate puzzle that is very difficult to manipulate, it might be better to you're going to prototype it on paper first anyway. So I guess I need further information on what you mean by start at the end, because I guess that could be taken in probably 5 or 6 different ways. This question is probably irrelevant or wrong place to say, but I watched Blueprint Communications a while ago, and I still don't understand what the event dispatcher does. Well, that's cool. I got to use one here in a minute, so I'll show you one more example, and then hopefully that'll help. How would you approach the difficulty level of puzzles to get to a point where it's hard to solve but not frustrating or impossible for people to get behind your logic? One, you'd have to have logic. All I have is just the rule set that clicking one light toggles that light and the others around it. If you are immediately setting up all the different light states just by themselves, then it's possible you could end up in an impossible to solve setup. If you set all the states using the surrounding lights, then you should be fine. And Lauren is asking, did you check that you're using the game mode in this map and also in the project? It came up in chat as something to check. Well, let's look. Typically, if I've got it set up in the project, that shouldn't be a thing, but we might as well look anyway. So let's go into our world settings and let's tell it, it is set to none, but I would have liked for it to have fallen back. And still that doesn't seem to be doing what I want. But I'll leave it set there anyway. So let's see, also double check on game mode. Is it all still just disconnected? No, it should still be doing something. But that's okay. We'll look at that here in just a minute. And then I missed something. How did he guarantee the child meshes would all slot into place at the correct location? Oh, I cheated, kind of. There's really no such thing as cheating in all this, but if you take a look at my meshes, each mesh is already in its correct location because I didn't want to solve it that way. So when I modeled out the shape for the puzzle in Maya, I just made sure that I modeled all the buttons in the proper locations and then exported them that way. So I have 12 different meshes, each with their own correct location. So that should answer that. Okay, so let's see. Let me go ahead and work on the HUD, and then we'll come back and figure out why the game mode feels like it's being stupid, and I'm sure whatever it is, I will find some way to get it solved. For now, I'm going to go ahead and close it. I'll also close the game state, and we don't really need the parent button class open, and we don't need the pawn class open. So over here in my blueprints folder, let's create a new folder that I will call HUD Blueprints. Open this up, and in here, I'm going to create a new blueprint class that I'll actually base off of the HUD base class. And the only reason I'm doing this is because you can associate a HUD with your game mode. So I'm going to have my UMG HUD have all of its logic for setup in this class. That way, if you wanted to change out for different HUDs, you just have different HUD classes that you would just specify in the game mode. Let's call this ball, puzzle, HUD. Like so. And then we're going to build up our UI using a couple of different things. One, we're going to have our main UI, but each one of those is going to have its own special indicator light for indicating whether a light is on or off. And we're going to do that by making a user widget. So let's make a new user interface widget blueprint, which I will call button indicator light. Open that up. Now here's how the indicator light works. So I've got a couple of textures here. We have button layout and button HUD center. Let me go ahead and bring in an image. And I'm going to set this image to be, under my brush settings, we'll set this to be the button HUD center. So you see it's just a little circular button. Now it needs some fairly specific size set up for it, so we're going to set this to be 64 by 64. So it's a square. We're also going to move it up into the upper corner of the canvas, like so. Then we are going to set its color and opacity to a very dark and halfway transparent brown. Like so. So click OK. Now that's it. That's all we have to do for that, but we do need to put some logic behind it. So this is an indicator light. It's going to have its own behavior for whether or not it should be lit up or not. And here's how we do that. We're going to set up a custom event on this that we will call setState. And all this is going to do is take that button indicator image, which, just to be clean, let's go back over to the designer and let's name that. Let's call this the button indicator. We do want to make sure it's a variable. It should be by default, but it's a good thing to double check. We're going to drag it into the map, get, and then we are going to set color and opacity. Now, our custom event here, we are going to add an input, and that input will be a Boolean, which we will call state. Now, for the colors that we use, let's just say we select a color, A or B. So B, we will make pretty much this, it should be the same. Like, if I were being really anal about it, I would probably grab the actual hex values for the color I just set up a minute ago, but a nice dark transparent brown for kind of the off state is fine. And then for the on state, we'll go to a very pale illuminated orange. So something kind of like that. Now we can take our state and plug that into pick A, and there we go. So when we call set state, we're going to send it a true or false value, and that will just set this to either be on or off, which is all we really need. So let's compile and save. So now we need to build the main HUD. So let's go back over to our HUD blueprints. Let's make another user interface widget blueprint. And we'll call this the main UI. It should probably be something like ball puzzle main UI, but I'll keep it fairly simple. We're going to start this off by having a canvas as our initial panel for layout. Just bring in a canvas panel. I'll make it an indeterminate size. We'll probably resize it later. And then I have a couple of, well, I have one image that I've created to kind of help me line this up. It is called button layout. So we're going to add that in, and it needs specific sizes to look right. So that's going to be 256 by 256. There we go. And let's just take my canvas, make it a little bigger. Now this is just here to help us figure out where the indicator lights are going to go, but it can have its own color and opacity. So we'll make this blue, make it a dark blue, and we'll give it some kind of fade so it's kind of soft, doesn't look quite so obvious. Next, we're going to add a lot of our button indicator light user widgets in here. So now that we created those, you'll see them at the bottom in user widgets. Now, I'll be honest with you, you could spend a little bit of time lining all these up so they fit perfectly inside each one of these circles. They will align. In fact, that one looks pretty good. I don't expect all of them to align that well. This is the kind of thing where if you're building this on your own, you could spend that kind of time. But for the sake of a live stream, it's probably not as important. I'm just going to get them kind of inside those circles with a certain amount of accuracy, and we'll move on from there. Okay, so we've got all of that. Let's grab the image as well as all the indicator lights. Let's hit Control-C, come up here to the canvas panel and hit Control-V and paste them all in. Would have been nice if they'd come in relative to their original locations, but that's okay. Again, if you wanted to spend the time to really position these with a lot of precision, you could. I'm not going to worry about it. Let's get them down here, and then I'll just get them somewhere into their circles. Now you'll notice I don't really care about the order in which these are in here. I'm going to have to sort that out though because I have to number each one of these. Also, let's grab everything in there like so, and we will drag it all to the upper left corner of the canvas panel, and then we can take the canvas panel and kind of collapse it around everything. So we'll move that to the edge of the screen. I would also like to add a text value in here as well. So this will be just a number that we will use to update how many lights are currently active. So let's do this. Let's take its color and opacity. I'm just going to set it to a nice vivid orange color. We'll center it and put it right down here. And make sure it's a variable because we're going to talk to it later. We'll call this active lights. Now we need to figure out which of these indicator lights go along with which button, and that is where our initial work for setting up the debug numbers is going to come in kind of handy. So if I hit play and I hit D, we can see the arrangement of numbers and kind of how they work. Now this might be a little hard to make out on the live stream, so you'll have to take my word for it. We go 1, 2, and then we spiral 3, 4, 5, 6. Or 1, 2, 3, 4, 5. And then, once we hit that, once we hit number 6, from spiraling around, we jump down to 7 and continue the spiral to 8, 9, 10, 11, 12. So it just kind of spirals around down from one pole to the next. So we're going to make our number setup in the UI correspond to that. To make my life easier, I'm just going to take a moment and rotate the puzzle in kind of the way I'm expecting. So it's 1 and then 2 is pretty much straight up from that. So let's stretch this out. And then I'll zoom in to make this a little easier to see. And I'll just do some wacky things with my user interface. This is another area where it's nice to have 2 monitors. So we'll grab the button here, and you see it gets highlighted. We will select it, and we will rename it button_01. Straight up from that, we have button 2. Spiraling around from that, we have 3. So that looks like somebody figured out why my game mode isn't working. That's okay. That's what happens when you're giving a demo. I have built this game like 3 times now, and it's worked every time. It's just what happens late in the day. So hang on, let me keep plugging through this. Let me. So here we are on number 3. So let me get these named real quick. Button_03, and this will be 4. And button_05. And button_06. So that's the top hemisphere all named and ready. Now, we have to kind of pay attention to where this button right here would fall. So technically this falls in between buttons 5 and 4. So let's just rotate the puzzle around. In between 5 and 4 is number 10. So let's just go ahead and select that button and we'll name that button 10. And we'll rotate the puzzle so that we're staring at 12. Spinning around counterclockwise, we go to 9. Then 8. Then 7. And then we jump to 11. And finally, the one in the center should be the South Pole, which is button 12. So you can see at least how our debug numbers kind of helped us set up our UI a little more easily than it would have been otherwise. So now that we have all of those named, we are ready to start making some associations and get the UI all hooked up. We're going to do the main hookup, however. Let's go ahead and stop playing. We'll do the hooking up inside. We'll do the hooking up. That's great. We'll do that inside Ball Puzzle HUD. So let's go into its event graph. And we'll say on begin play, we are going to create a widget. We will get the owning player controller for this HUD. And that can be the owning player. We'll set our class to be the main UI. We will then add this to the viewport. Compile and save. Over here in our level, make sure you go up to your blueprints. Come over here to your game mode. Hi, game mode. We'll deal with you in just a minute. We want to make sure that in our settings, our HUD class is set to our ball puzzle HUD. Otherwise, none of this will work. So now if we play, if I put my UI back where it belongs, pink, aha! We see our user interface. Its positioning could probably be a little better, but that's okay. Let's go ahead and stop. Let's put our screen back to something a little more rectangular. And that's actually pretty good. I mean, you could just take the canvas and move it around. Obviously, all the buttons are offset by like a little bit, which is making my internal OCD a little bit crazy. But right now, the HUD is there. It's pretty, but it doesn't do anything. So now we need to make sure that we can update the HUD. Now, before we actually do updating, let me look into this. So somebody on the chat, Bahalzen, as I butcher your name in gratitude for helping me out here, said he connected the not output to the scalar value, and it will be backwards. He'll have true in the variable, but false in the scalar. Well, that was beautiful of me. That should be able to be fixed over in the button parent class. And sure as hell, I took the not value and plugged that in. So let's just do this. Let's just grab button state and plug that in instead. Or since we've got it right here, we could just take the output right there and plug that in, and that should work. So let's hit play. Actually, I should probably double check in the game mode that I reconnect all of this malarkey. So let's go toggle button state. Actually, I'm going to try this and just let it run once, see what happens. Oh, and it turned everything on with a little half-second delay. So thank you, Bahalzen. You can laugh at me trying to pronounce your name. Stupid American, right? And what I'll do real quick is we'll put a branch in here. And we'll connect this up. So really quick, as I scan up on my notes, it's just one of those things you do when you're building something. In my notes, it actually is set up like this. But when I was building it for you guys, I just connected the knot from here, and that was a bad move. But fortunately, I have awesome users like you guys to help dig me out of little pits like that. Okay, so click play, and there we go. So here's the thing. Right now, this is choosing just a random setup of lights. By the way, ignore our UI for now. It's there, but it's not functional. This may or may not be solvable. I'll be honest, I never did the math. I think it should always be solvable, but somebody may be able to do the matrix math and tell me whether or not that's actually true. But this does illustrate why it's nice to have the UI. However, if when you call toggle button state, you also call toggle surrounding buttons, then what you do is you randomly hit all of the buttons in the same order you would, or the same manner that you would if you were playing the game. So at the end of the day, your solution simply becomes to play the game backwards. In this case, I got a really easy one. I just click this and the game's all lit up. So what I found is it's a good idea to kind of play with both, or maybe run this whole outfit in a loop, like basically do everything we do here in a loop like 5 to 7 times, but your mileage may vary. That's something that you could play with. The game is very easy if you also toggle the surrounding buttons. It can be very hard and potentially nigh unsolvable if you are toggling each state individually. So again, thank you, Balzen. As a reminder for anybody who was watching, I should have just connected the final output of the button state into the value for the scalar parameter. Because what I had underneath the hood is that the state of the buttons was set properly, but the materials were not reflecting that. And that's just my fault, and a really fun mistake to make. Okay, so now we need to set up some functionality for our user interface, and this ties into an event dispatcher that somebody was asking about before, because they didn't realize how event dispatchers work. I will confess, event dispatchers actually took me a while to wrap my head around as well the first time I ever use them. So what we'll do is we are going to start off in our game state, which is going to be responsible for kind of keeping track of the lights that we have active anyway. So let's start there. And we're going to make a function in here, which I'll just go ahead and build up as a custom event. That's fine. And we will call it update lights. Oh, I have to type custom event. Thank you, custom event, which we'll call update lights. All update lights is going to do is grab that button list. For each button that it finds, we're going to figure out what the state of that button is. So it'll be like, go one by one and say, hey, what is your current state? Easy to do. Just say get state. So there's your get button state right there. Now that we have that, actually, you know what? I'm going to do this a different way, and I'll show you why. If I take this true-false value, I could very easily branch this, and if true, I could add a 1 to some given value. The problem is I would then need to flush this value. Basically, I'd have to zero out the value whenever we call update lights, then do all my math to figure out how many active lights there were based on state, and restore all of that. Here's what I'm going to do instead. Let me grab this and cut it because I'm going to use it in a second. Let's do this as a function. If I do this as a function, we get something kind of cool out of it. We can say, well, let's call this update lights instead. Now, here within the update lights function, I can make a local variable called active lights. And this active lights variable can be an integer. And the nice thing about it being a local variable is that when we call this, it'll do all the math, it'll use this number, but as soon as we're done with the function and the function is finished, it flushes that whole variable out because it only exists within this function, which is super useful for us. So let's use that instead. I'm going to paste in what I had a second ago. Let's take our button list, we'll do all this stuff to it, and if it turns out to be true, if the state is true, then let's grab our active lights, and this is so cool, didn't always used to be here, we will increment it. That's it, that's all we need to do. So that is keeping a running tally of the number of active lights that we have. Now this is where we need to make our event dispatcher. The game state is going to have an event dispatcher that is going to call out a signal. So here's your quick review for event dispatchers if you can't remember how they work. Think of an event dispatcher like
a little noisemaker that the whole world can hear. No, I don't like that one, because I would abuse that way too much. I actually have to go back to my old tried and true explanation for event dispatchers. They're like Twitter. They are so like Twitter. In every single way, they are like Twitter. You set up a Twitter account. All the people who care about you will listen in. They will follow your Twitter account so that whenever you make a tweet, they receive it and they can do something. If they're not following you, they never receive that message and it doesn't matter. Their lives go on regardless. Even if nobody's following you, you could just be tweeting and it would work. Everything would be fine. It's not like the world would crash or anything. But nothing would happen in response. So that's what an event dispatcher is. And here's what I mean by that. Here's how it works. Here inside of our game state, let's make an event dispatcher. Now this is like setting up my Twitter account. I'm going to call this Twitter account, this event dispatcher, update UI. Like so. Now, this is going to have to send out some specific information. We are going to have it send out our button list and send out our active lights. Think of this as the content. Basically, we're having to guarantee that whenever we make a tweet, we're going to send out this information every single time. So like if you set up a tweet or a Twitter account for what you ate for breakfast and how much you weigh every morning, you'd have to make sure that every time you tweeted, that information was included, and that's exactly what we're doing here. We're going to do it by way of inputs. We'll make a new input, which we will call button list, and we will make its type of button parent, and we'll make it an array. Next, we'll add another input, which we will call active lights, and its type will just be a standard integer. So whenever we tweet from this account, we have to include those two pieces of data. Otherwise, this won't work at all. Okay, so now when we finish updating all of our lights, so here on completed, we are going to drag our event dispatcher. Watch this. Drag the event dispatcher out and choose call. This is like making a tweet. So I've got my account set up and I just made a tweet, but I have to include this data. I have to include what I had for breakfast and how much I weigh. So let's take the button list and I'll connect that here, and the active lights, and I'll connect that here. You will see why I included that data in a minute. If you don't yet understand why I'm doing that, don't stress. It's not important right now. So this is just like making that tweet, sending something out into the ether for all of your potential followers to be listening out for. So now we need to set up who's listening out for that tweet to take place. And the one who's listening is going to be our main UI. This is the guy that cares about it. So let's, real quick, let me take my UI. I'm going to kind of center it up vertically on the left-hand side because that makes me happy. Next, let's go over to the event graph. We have event construct and event tick. I do not want tick. Tick can go away. I do want construct. That's kind of like begin play for this UI. What we will do is we will get our game state. I can't type today. So we'll get our game state. We will, as before, cast that to the puzzle game state. Now let's go ahead and make that a pure cast, like so. Then we will assign our event dispatcher. We can say assign update UI. Now I'll give you just kind of a general hint. Assign is a bit of a shortcut, but this is a way that we can tell the UI, we tell this class that it is now following the update UI Twitter account. Boom. And here's how it works. On event construct, which is a lot like begin play, we make a bind event. That's actually what's doing the work of following that event dispatcher, but we need something to happen in response. Just receiving a Twitter is nothing, but you probably do that to most of your friends, right? They tweet something, you're like, oh, great. But sometimes that person you care about, like maybe a significant other or whatever, like your significant other says that your significant other tweets, I just rear-ended a cop on the interstate. You would respond, right? You'd be like, oh my God, where are you? So I can drive to you and yell at you for being somewhat dumb. What you have to do though is set up some sort of an event that takes place in response to receiving that tweet. And that's what this is all about, this little event with a little red wire connected here. So by choosing assign when I dragged out update UI, how I saw assign, what that did is that created the bind node, it created the event node, and it went ahead and attached them all for us, so it's just a shortcut. Okay, so now we are doing something in response to receiving a call from update UI. What are we going to do? This is where things get a little bit fun. First off, we have two things we want to do. Whenever I have more than one thing I want to do, what do I think of? I think of a sequence. So let's add a sequence. And the first thing we're going to do in our sequence is we're going to set the active lights. Remember that active lights we set up, that text object? Let's drag that in like so. And then, I love this stuff. This stuff is so cool. Because I still remember back before I could program my UIs with blueprints, so I get super excited doing all this. So let's take active lights, and we're going to set text. So set the text value to something. We don't know what, but we're going to set it to something. And there we go. But remember, we brought in active lights, right? We brought in that integer. Well, let's just plug that in. Aha! Look at that. So we're automatically setting that. So what happens now? What's the next thing that happens? Well, we need to set up all of those indicator lights. And this is a little complicated. What we're going to have to do is go through our list of buttons and say, you, should you be on or off? Okay, you, should you be on or off? And we're going to do that like 12 times to figure out who should be on and who should be off. And here's how we're going to set that up. We will start from our button list, and we will do a for each loop. Let me go ahead and connect that. That's the second thing we're going to do. So this is just digging through the list, and for each thing in the list, what do we actually want to do? We want to set the state. Remember that thing we did for, I'm sorry, that's not what I want to do at all. So we have our access to the buttons. We want to get the state. So get button state. So now we have access to whether or not that button is lit or unlit. And now what do we do? Well, we have to take each one of these little child, these user components. Remember the button indicator lights that we made? And we need to set state on them. Remember that little custom function we made? If you forgot, let's do a really, really fast review. If I go under my HUD blueprints and go into our button indicator light, we have this guy. We have to call set state. It's going to take an incoming state value, and it's going to set whether or not that light is switched on or off. Okay, cool. So with that understood, let's go back over to our UI. But how do we choose the right button for our incoming piece of data? You could just hope that the indexes of the button list array are in the proper order and try it that way, but I wouldn't count on it. In case things ever get populated in a different order, you don't want to rely on that, which is why we set up that button ID a long time ago on each individual button. So what we can do is grab this guy and say, get button ID, and we're going to use this on a select node. Plug that into the index. Now, we have to add a lot of inputs here, so let's add an option pin. And an option pin, I need a hotkey for this. So we have to add a total of 12 of these. There's 6, 7, 8, 9, 10, 11, and 12. Now, this will work. But remember how I made my list 1-based and not 0-based? That means I'll never actually hit option 0. So to make up for my shortcomings as an artist, I am going to add an extra option pin, and we're just not going to use option 0. Because you're never going to hit it. Again, somewhere there's a programmer who just got really queasy, and I understand. It's fine. But we're just going to take each one of our buttons, and now they... Oh, woof. Now they plug nicely into each one of their own individual slots. So, thank you. This will start to clean up as I plug these all in. So let's take 11, plug in, 10, 9, 8. At least there's a low number of these where you just kind of have to sit and watch me plug stuff in or rename stuff. But it does happen. 4. 3, I feel like I need a drum roll. 2, almost there. And then 1. Yes, all right. And then we're amazing. We've figured it all out. So we'll do even spacing on all of these. We'll position this guy down here at the bottom. And there we go. So now, each time we pull one of these buttons out of our list, we say, hey, what's your ID number? And based on that ID number, we figure out which one we should be talking to, and we pass that into our set state. So now we know, we have guaranteed that we are setting the state for the appropriate button. That wasn't that hard, but it also kind of explains how the event dispatcher things work. I know it's a little bit confusing. Honestly, the best way to wrap your head around event dispatchers is start with something very small and use a few. Like, build a very, very basic one and branch out from there. Because until you use them, it's going to be hard to wrap your head around them, and even harder to remember if you step away from them for a long time. So let's compile. We now have this working, but before it's actually going to do anything interesting, we need to hook that up in all of the locations that are relevant. So the first place is going to be in our game mode. So as soon as we're done setting up all of our surrounding buttons, let's call update lights. So let's just get the game state. Did I already do that once here? I should double check. I did. So I can just grab a wire from way back here and just say update lights. Like so, and we could test that. So if I hit play, boom. It says that I have 6 lights on. There's the number there. There are my indicator lights all fired up. And as I rotate around, I should be able to count them off. 1, 2, 3, 4, 5, 6 are on. But here's the thing. Right now, if I click, the UI never updates again. So we need to fix that. Let's Alt F4. Let's go back over to our button parent class. And as soon as we finish toggling the state of a button, let's immediately get the game state, which I don't think we've done anywhere else here, so let's do that again. We've done it a few times already. Get game state, cast, pure cast, drag wire down, and then just call update lights. And that should update everything. Boom, so compile and play. And it says we have 6 active. I click, we're down to 4 active. It says 4 on the HUD, and I see 4 here. Now it says that 1, 2, 3, so let's see, button 1 and 1, 5 should be lit, so let's hit D and double check. So yep, 1, I know it's really hard to see, but it's there, and 5. So yep, everything is working and corresponding, and our game, as far as the prototype is concerned, is complete. I mean, there's all kinds of polish we could do from here. We could make the UI look a little bit better, obviously, even just by aligning some things, that would help a lot. We could set up a win condition and a lose condition. We could add sound effects, right? Because this feels like it should like rumble while it's rolling, and maybe have like a beep or a boop or something when you actually hit a button. All kinds of fun things you can do. But I will leave that to those who would like to explore it. The main game and all of the difficult parts of logic and all the stuff that you've really got to hammer on are all done now. So that wraps this up. Let's see if we've got any other questions that have come in. So I'm going to, well, stop playing the game, and let's slide over to our questions list. And I think that's all of them. I don't think we've added any new questions. Hopefully we were able to make the event dispatcher thing a little clearer. I would recommend that you go back and review the Blueprint Communications video that I did a while back. After seeing this, try to correlate the two. If you're still having problems, get active on the forums, right? Tell people what you're trying to do, how you're trying to employ an event dispatcher, because it's possible that you're trying to use one in a way that it was never meant to be used. And someone might be able to jump on and be like, oh, I see what you're trying to do, but don't use a dispatcher for those, use this other thing instead. Or they might say, oh, you're just wiring it up wrong, so here's how you do it. So make sure you're using all of the community resources that we've got out there for you. So I'm not seeing any new questions. We've been rolling and kicking butt on this for like the last 2 hours. So I want to thank all of you that stuck it out and actually watched all this video. I want to send a huge, massive thank you out to Behalzen, sorry, for helping me dig out of the random thing where I misplugged in a blueprint. Even bigger thanks to all of you guys who are out there using the engine day by day, who are building up our community, making Unreal what it is today. Honestly, without you guys, the engine would be nowhere near what it is right now. So thank you all so much, and we will see you all on the next Unreal training stream. Take care.